All right, we are going to do just the first part of 6-4, okay? It's Friday, we're missing people, we're only going to do like the easier part of this section. Okay, it'll get harder later in the section, but for today it's not that bad. Today we are focusing on rewriting radicals in exponential form. So you can go from a radical to have an exponent that's a fraction. Like there's different forms to write these in. So we're going to flip back and forth between the two forms. So then writing rational and radical, and then we're going to get into simplifying with rational exponents. So sometimes it's easier to simplify when there's a radical over it. Sometimes it's easier to simplify when there's a fraction for an exponent. Just kind of depends on what you're looking at. That's when it gets a little trickier. Okay, so we know the index number, right? It's this number here. When you rewrite, that becomes your denominator. So, for example, if I had the square root, what the heck is that, of x, that would be x to the, what exponent's on this x? 1. And then the index is 2. That's x to the 1/2 power. So what happens is you can rewrite these in two different forms. And that's what we're going to practice today, is literally just going from one form to the other form. That's what we're practicing on. Okay? So students always get confused, like whatever like you have here versus like, do I put the index number on the bottom? Do I put the index number on the top? Like sometimes you just get confused like which one goes where. So think of an index. This is like your root, right? We say it's the cubed root, fourth root, fifth root. Where do roots grow? Underground. Underground. Bless you. The root number, the index is your root. The roots grow underground, so it goes under the fraction. I'm trying to help you remember, right? I like goofy ways to remember things. So radical expressions can be written in exponential form. What's exponential form mean? It has an exponent. Look at that, fancy term. Exponential form just means it has an exponent. Rational exponents can be written in radical form. So all it's saying is you can go back and forth between the two forms. And the reason we do that is because if I'm multiplying like a cubed root by a fourth root by a fifth root, we can't multiply if they're the same root, or they're not the same root, right? Like we talked about that. If one's a square root and a cubed root, I can't multiply those together. They're not like terms. But if I rewrite them to have a fraction for an exponent, what do you do with exponents when you multiply? What do you do with exponents when you multiply? You add them. I mean, go back to if I had x squared times x to the fifth, what would you tell me that is? It's x to the seventh. So if I would have x to the 1/2 plus x to the 1/5, you could just add, it's not 1/7. You have to have common denominators when you add. But you could add those together then and get an answer, right? But if I would ask you to multiply the square root of x times the fifth root of x, you'd be like, I can't. Because the roots aren't the same. So if they're in this form, I can't multiply them. If they're in this form, I can, because then I add exponents. So it changes what we can do and what we can't do with a problem. Okay? They're trying to add that together. It'd be 10, so it'd be 5, and that'd be, yeah, it'd be 7/10. Yeah. Yeah. But do you see what I'm saying though? Like if I gave you this, you'd be like, you can't, because the indexes aren't the same. But if I give you this, they are right. That is x to the 7/10. I can actually do that. Hold on, what? Do me a favor, at this point in your math career, if me going 1/2 plus 1/5 is 7/10 and you're like, what the heck did she do? Use your calculator. I don't have time to reteach you how to add fractions at this point. That's like a 4th or 5th grade level math. So if you want me to do it on the side, I will. But if you're like, what did she do? Just use your calculator, type it in. It'll give it to you, okay? I just don't have time. But if I gave you this, you'd say I can't do it. if I give you this, you could do it. Because they're fractions, like I add fractions when I multiply. So that is why we have two different forms though, because one form I can't do anything, one form I can. So it allows us to be able to do stuff with these. So today is just to practice going from one form to the other form. Before we even get into any of the math, we're just going to practice rewriting. Yep, that's all we're doing today, we're rewriting. So the fifth root of 9, how would you write that with a rational exponent? This would be 9. What's the exponent on the 9? A 1, and then my root underground is 5. So this is 9 to the 1/5. Means the same thing. And it goes underneath. The root goes underground, right? So that's why, remember, it goes under. So what would the cubed root of 10 be written as? To the 1/3. Right? It's always, the top number is your exponent, which there isn't one, it's just a 1, and the bottom is your root. One half. Yep, that's the unspoken 2 that's in there. At this point today, don't worry about simplifying. We're just rewriting. That's all we're doing. What about the 8th root of 5x? Five x 1/8 like this? I disagree. Hold on, somebody's gonna, you're close, but that's not right. It has to be on both or parentheses. Because what do we know about exponents? They only go to whatever they're right next to. So if I would just write 5x to the 1/8, well, that would tell me the x is underneath the 8th root, but the 5 is not. Because the exponent here would be a 1. So if you if you have more than, yikes, my board is not cooperating today. So if you have more than one thing under here, it needs to be in parentheses, saying, hey, this entire group was under here, so this entire group is to the 1/8. Okay? Here's 5 of them. You try. So number 1, Taylor, what'd you get? Beautiful. Number 2, Luke. 33 to the 1/5. Number 3, I don't need that. Jonas, number 3. Make sure when you're reading these to me, guys, make sure you're saying it's to like the 1/2 power. Because if you just say 93 1/2, I'm thinking 93 1/2. Like, just make sure you're careful on that. Number 4, Sam. Beautiful. If you don't put that in parentheses, is it okay? Has to be in parentheses. Entire group is underneath, entire group. And number 5, Jasmine. Beautiful. See, I told you today's easy, right? You okay so far? Those of you that just walked in, real quick recap. We haven't missed a whole lot. We are practicing today, writing back and forth between the two different forms. So that way it allows us, next week we'll get into different ways to kind of put all these numbers together and kind of work with things better. The index, or we can think of that as your root, right? It's the 4th root, 5th root, 6th root. Roots grow underground, so it helps us remember it is the denominator of the exponent. The exponents go as the numerator. So it's exponent is on top, the root number is on the bottom. Real quick, everybody grab your calculator. So this is a little side note. If I asked you guys what is the cubed root of 27, what would you tell me? It's 3. How would you rewrite this into this form? 27 to the 1/3. Grab your calculator. I want you to see this. So type in 27. I know what you mean, yeah. So type in 27, hit your little caret button for an exponent, and then type in 1/3. What? And it gives you it's 3. And you guys know the cubed root of 27 is 3. Like, we should know that. But I want you to see it does work. They work hand in hand, so just the different forms. Okay? All right, next part. Can you work it backwards? I'm telling you, today is not that hard. That 5 would be over there. Over where? In the index? Yeah, that's the 5th root of 3 to the 1st, or the 5th root of 3. Remember, the root is underground, so the root number is at the bottom. Yes. When there's more than one thing. Yep. 16 to the 1/2 would be written as, what root is this? 2, the square root of 16, which is 4. You should know that, right? Square root of 16 is 4. How would you rewrite y to the 1/7? That'd be the 7th root of y to the 1st. We're going to look at some other exponents here in a little bit. How about 9x to the 1/4? What root is it? So the 4th root, I need you guys to learn how to say these, the 4th root of 9x. Yeah, because I read the answers to you guys in the proper form, so hopefully you start picking up on that, how you say it. What about 5x to the 1/3? There's no parentheses, so what's that mean? Jonas? Yes, because what's the exponent on the 5? It's a 1. So does it go underneath the radical? Does it have a root? No. The 5 is actually outside, and then it's the cubed root of x. So be very careful. Do we notice the difference? Here it was in parentheses. It meant the entire piece was to the 4th root. Here, the 1/3, so my cubed root is only on the x. The 5 is just outside. You got to be very careful on that. Parentheses make a huge difference. All right, your turn to practice. 6 through 10. Take a minute, rewrite those. Taylor, you look thrilled. Can you tell me number 6? How do you say this? The 6th root of 19. Good. Dakota, give me number 7. Good. The 3rd root of r, or the other way we could say that is the cubed root of r. Yeah, it's got the other word on there. Adrian, number 8. Describe to me what it looks like. The square root, that? What goes under here? 8. Can we simplify that one? Square root of 8 is theoretical too. That's right. Thanks. All right, so what about number 9? Let's see. John? No. Tell me what you got. No. Tiffany, what do you have for number 9? This number is your root. This is your exponent. So it's like this entire thing is to the 1st. Does it really change anything? You don't need the parentheses. You can put them if you want them, but you don't need them. But no, she was absolutely correct. What about number 10? No. Keep going, Tara. You say it again? Luke? Luke, what you got? Incorrect. Dakota. The ninth root. That is correct. You said 14 to the ninth power. I thought you knew the right answer, but it was not the way you said. When you said 14 to the ninth power, that means like that. How about ninth root? Ninth root. Well, good. At least you know how to do it. Whether we need to work on how to say it. Okay. Okay. Now, this again, it's broken down very baby step. I've just already talked to you about this. That this top number is your exponents. The bottom number is your roots. Up to this point, your exponent's always been a 1. So now we're going to look at them if they're not a 1. What's it look like? Take a look here, though. Like, these are written just slightly different. They both have the root in here, the index number. Sometimes the exponent is written way up top by the end of the radical, which is weird. I personally don't write them that way, but just in case you ever come across it, it means the same thing as this. This is the way I would recognize. Like, I write them this way, with that exponent underneath here, not way up here at the top, because that looks weird. Okay, so let's go through a couple together. So the fifth root of 3 squared. To write it with rational exponents, it would be 3. The exponent is 2. Roots grow underground. That is 5. Right? Exponent on top, root on bottom. I can vividly remember right now sitting in my high school math class, freshman year, sitting there, learning how to do this. And like, I remember taking a quiz, sitting there being like, which number goes where? Like, I remember stressing out because I couldn't remember. Adrian put it away. I couldn't remember which one was the top and which one was the bottom. My teacher never taught me that your roots grow underground, so that root number is the underneath part. So hopefully that helps you, because I vividly can remember sitting. I remember right where I was sitting when I took this quiz, and I could not remember. I know, stupid, right? Like, why do I remember that? It was freshman year of high school, and I remember that. So I guess it really bothered me when I didn't understand something, right? So that's why I remember it. What about I guess it's not a number. What about the second one? This would be 6 to the 5 over 2. Because again, that's that unspoken 2 because it's a square root. Next one. Good. N to the n 11 over 8. Now, I know some of you are probably looking at these going, wait a minute, you can simplify those. Right? I can take a group of 8 out of here. I can take a group of 2 out of here. At this point today, I'm just looking at, can you rewrite? Okay? Yeah. Sometimes, yes. But for today, don't worry about it. Like, that's going to be next week, a lot of our focus next week. And then the last one up here. Two xy, and then what? 5 over 6, just like this? Parentheses. If you don't put the parentheses, I assume the 5 over 6 is only on the y, because that'd be what it's next to. So again, if you have a whole group underneath, make sure that whole group has parentheses on it. Guess what? It's your turn. 11. Hannah. Where do roots grow? There you go. Yes. And again, roots underground. Like, to me, like, that just makes sense, like, to remember that way. If you remember the number on the right goes on top, if that helps you, great. To me, that gets confusing. Number 12. Let's see, who haven't I picked on? Briley. 12. Good. U to the 2/9 power. Mm-hmm. Since you said to the, you'd been okay. I didn't know what you meant. If you just say and. Technically, then that's incorrect. It's a good thing I don't give you guys a verbal test, right? Some of you guys would be in trouble. Maybe I should look into that for the future. A verbal test. Monday's the future. 13. Brooke, 13. Good. 25 to the 3 halves. It's got that unspoken little 2 in there. Not today. Like, that's not what we're focusing on. Because once we get into simplifying, like, whoa. If you look further into your notes, you're going to see where all this simplifying comes. We're going to do an activity in class, and, like, people's heads explode because there's just so much. Next week, when you probably won't be here. I don't know. 14. Talk to me at that when we get through this. I do record all these. Yes, you can. It's right there. No, yeah, you can't hear you guys. Gavin, 14. Don't try it. Do I have another parenthesis somewhere in here? Okay. I assumed you did, but pretty much, yeah. All right. Rational exponents to radical form. Going back the other way now. So 5 to the 2/3. What root is this? 3. And it would be 5 squared. Again, for today, you can stop there. I'm just looking at, can you flip it to the other form? So c to the 13/10. What root? The 10th root of c to the 13. The quantity of 8h to the 7 halves. What root? 2. So square root of parentheses, yep, to the 7th. I want to make sure that 7 is going to both of them. So I need to keep them in parentheses so I know it goes to both. I just heard like 4 questions. Jonas, what'd you say? You could. Yeah, you could have written that as the square root of 8 to the 7th, h to the 7th. You could have done that. Means the same thing. I'm just lazy. How about 3r to the 3/4? I have a 4th root. What goes under there? Madi, say that again? Yes, the 3 goes on the outside, and r to the 3rd goes inside. Because again, the exponent on the 3, it's just the 1. It's not in a parenthesis, so it does not go to everything. Exponents only go to whatever they're right next to. It's kind of like in your calculators we've talked about, like if you would put in -2 squared versus in parentheses -2 squared. Right? Do you guys remember talking about stuff like that? Like this is something different than this. Right, we do the quadratic formula. It makes a huge difference, right? Because your calculator is only going to put this 2, the squared, on the 2, not the -2. They only go to whatever they're right next to. So that's why it's important to have parentheses or not have them. All right, your turn. All right, 15. You said that perfectly, by the way. Very nice. 16, Paige. Beautiful. Do I have to put the little 2 in there? No. Is it a good idea to maybe make that part of your routine, though? Yeah. You want to answer 17? All right, Dakota, 17. Don't make it harder than it has to be. And what goes here? 2. Yeah, don't make it harder than it has to be. I kind of see where you were going with that, though, because it had the exponent. Yeah. And then 18, Trinity. Six to the 9th root. Times, there you go, the 9th root. Good. I know you knew it, just getting those words out. All right, yeah, it's being multiplied, yeah. 6 times the 9th root of w to the 4th. All right, how are we feeling about switching back and forth 2 forms? Good. All right, we're almost done for today. Now, the directions to this point have been to just rewrite in the other form. So if I just ask you to rewrite, you don't have to simplify. But now my directions say simplify. So just a little bit of basics today, just to see if we're okay. So 49 to the 1/2 is 7. Because what does that mean? That means the square root of 49, which is just 7. Okay. Could you type that in your calculator? You could. So number 20, negative 216, notice it's in parentheses there, to the 1/3, which just means the cubed root of negative 216, which is negative 6. X to the 5/4 means the 4th root of x to the 5th. Can I take a group of 4 from there? Yeah. Any leftovers? And there'd be 1 leftover. Don't lose that index, though. That little 4 still stays with that radical. And then 8 to the 2/3, what's that mean? That means the cubed root of 8 squared. What is 8 squared? And the cubed root of 64 is 4. Okay, so in those cases, seeing them with rational exponents wasn't real helpful, right? They made more sense to switch them to radicals, and then I could simplify. Next week, we're going to get into, I give you different forms, and we have to do stuff with the numbers, and sometimes they're easier one form, sometimes they're easier the other form. We're going to work kind of through that next week. Okay? All right.